Welcome, everybody. Okay, so okay, so for the group project, here's a little incentive. For the group project, all right, AUM Research Day. AUM has Research Day coming up, right? AUM Research Day. Where was I looking at it? AUM has Research Day coming up. All right, people. So I'm gonna nope. All right. So AUM has Research Day coming up. For some reason I can't find it. All right, I'll post some more stuff about it later on. Anyway, so but AUM has Research Day coming up, and I want you guys to I want you folks to enter posters. I wish to have the Does anybody have any information on AUM Research Day? All right. All right, I'll come up with it another time. All right, anyway. All right, okay. So anyway, on Monday, we started to look at callbacks, right? And I started to show you this code. I'm going to post this code, by the way. Um, all right, let me post this code. All right. Okay, yeah. So we were looking at callbacks. We're looking at callbacks on Monday. And we said callbacks. All right. Does anybody remember why we use callbacks? What's the purpose of callbacks? Hmm? What is a callback? All right. Now, people, here's a general principle I want you to understand and know and embrace. You must never be stuck, right? You always have a way forward. There's always a way forward. Yeah. When now, I've been trying to tell the people in leading innovation that as MIS students, we're preparing you to be the leaders in the organization. Everybody with me? And you have to understand something about when you do a master's. When you do a master's, you're no longer qualified to do the jobs that require a bachelor's. Everybody with me? I cannot apply for jobs that require a master's anymore. You know, you rather, you know that? In other words, I have a master's degree. But the fact that I also have a PhD makes me unqualified to do the job with a master's. Why? Why is this? Tell me. Tell me. Let's talk about this. Let's talk about this. Let's talk about you can go on the internet and learn deep learning tomorrow. You can go on Coursera and take a deep learning course tomorrow, right? But I want to understand. I want you to understand what it is you're doing here, what it is you're doing sitting here in this room, right?
Level of abilities don't match the job role.
Your level of ability has either grown or become more specialized. And I understand something.
I think the level of education or
Right. So what happens is that when you change something, it becomes better for something and worse for something else. This is the fundamental issue in life, right? When you change something, you become better for something and worse for something. When you do a master's, you become better for leadership and worse as a follower, right? Because you're going to sit down and think, this leader is not analyzing things properly. This leader is not taking the right approach. This leader is not. So you no longer fit to do jobs that require a bachelor's, right? This is the problem. So it means you have to, when you have a master's, when you have a master's degree, you have to have a matching. So in other words, when you have a piece of paper that says you have a master's, right? We're trying to give you a piece of paper here, right? But we're trying to give you more than the piece of paper, right? Trying to give you more than this piece of paper. We're trying to also give you mindset, attitude, approach, habits that make you a leader, right? All right. So come back to what I'm trying to tell you right now, which is that you must never feel stuck. You must never be stuck, right? And a specific example of that is if somebody asks you a question and you don't know the answer, think what's the nearest thing to the answer that I know, right? What's the nearest thing to the answer that I know? Everybody with me? We're inching towards the answer. When you had a bachelor's, you needed to know the answer, right? You were taught the answer. In high school, you were taught this very specific facts that represented the answers to questions, right? When you do a PhD, you're taught how to find the answer. You're taught how to do research, right? There are no answers anymore. So when you do a PhD, it's all about finding answers, right? Somewhere in between, you have the master's. And in the master's, you're taught some answers. You're taught how to find some answers. You're taught how to figure out some things, etc., etc. All right. So here's what I'm trying to tell you. Here's what I'm trying to tell you. Is that if I ask you what is a callback, you shouldn't sit there feeling stuck. Callback. You've probably never heard it before this week, but it has two words in it. What's the first word? What's the first word? Huh? No, callback. Callback. What's the first word? Call. What does it mean to call something? It can be run something if you're coming from a programming standpoint, yeah, right? Run something, right? What does it mean otherwise? Call when you call something. When your mom called you, right? You didn't tidy up your room. Your mom call you. Your mom call you, right? Bala, come and tidy up the room. Right? 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 So to call something means to what? You seek a response. But we're halfway there already. See that? All right. If you call it back, what does that mean? Bala, come and tidy up your room. Bala comes and tidies up his room. Mom goes and checks. Oh my God. I teach this kid how to tidy up the room. Didn't tidy up the room properly, right? Bala, come back and tidy up the room. Right? Call back Bala. You see that? Right? You see that? That's the problem, when you sit near the front. Right, Trenny? I know Trenny tidies up her room properly now. Right? All right. Rashmita, you keep your room tidy. All of us coming to check after this. We're gonna come see a tidy room. So to call back something, right, means you bring it back, right? That's all that's happening with this callback situation. Yeah, that's all that's happening. So if I tell you we're looking at callbacks, we're simply looking at something that we've referred to over and over again. We're bringing it back over and over again. See that? And so the point is, this is how I want you to approach. This is how I want you to approach your life, leadership, knowledge, etc., etc. Go from what you know, right? Always go from what you know. Always refer to what you know. Build on that. Search for clues. Yeah. Now, this is very important though. Don't just go off what you know arbitrarily. If knowledge is available, right? And knowledge is always going to be available on the internet, right? This is why I don't teach from a memory standpoint anymore. Memorization is dead. Memorization is a waste of time, right? That's waste of time business. You don't need to remember anything anymore, right? You practically don't even need to remember your name anymore. You can pick up your phone and look at it and see your name, right? But you need to know how to figure things out. You still need to know how to figure things out, apply things, know when things are necessary, know what is right for each situation, right? This is what you're here to learn, right? So what I'm trying to tell you folks, is that I feel distressed when I ask a question and you guys just sit there looking scared, right? I want you to try something. Don't be afraid to look silly, right? Don't be afraid to get it wrong. You have to get it wrong sometimes before you get it right, right? And failure, in the old days, times are changing. And sometimes I like the way things are changing. Sometimes I don't like the way things are changing. But times are changing. And one of the things that we're embracing in society these days is failure. Yeah. There's a new attitude to failure. Some people say fail fast, right? Some people say fail upwards, right? Talk about failing fast, right? Business management concept and theory encourages business to identify and address failures early on rather than invest, blah, 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 right? Just get the failure out of the way, right? In Jamaica, we said nothing beats a trial but a failure. It's kind of a weird way of saying at least try something, even if you fail, right? There's the idea of fail upwards, right? Right? No, no, okay, no. Depending on who you ask, they might, it might sound like a good or a bad thing, right? It might sound like you've been rewarded for failure. But what it is that you've tried a bunch of stuff. You've had some successes and some failures, but the successes outweigh the failures, right? All right. Anyway, preaching. So today we're looking at callbacks, right? And what we're saying is callbacks allow you to check on what's happening in the model training, right? So you have this model. Let me upload this to Canvas, by the way, right? You have this model, right? And the idea is that you have this model. And the idea is that we can check on what's happening in the model, right? We're not just going to let the model run wild and run free. We're not just going to let the model run and use up computing resources. We talked about compute on Monday, and we said that, no, here's one of the things. Here's another thing that I like about the way the world is moving. We're not just doing stuff anymore, right? And looking at, for example, the financial cost, right? No, I mean, we're never just doing stuff and not looking at the financial cost. What I'm trying to say is we're not only looking at the financial cost anymore. We're looking at human cost, societal cost, environmental cost. So here's the thing you have to understand. When we train a model, yeah, there's a cost to it, to the environment, right? Because the point is that these models, not these little tiny models that we're training right now, but when you train large models, especially large language models, right? When they train ChatGPT, for example, right? So ChatGPT, how many GPUs was it trained on, right? 10,000 to 20,000, right? Now, each of those GPUs is drawing something like 1,200 megawatt hours of electricity. You see what's going on here? Right? Or to put it in perspective, 550 tons of CO2, which is the equivalent of 110 gas-powered cars over a year, right? All right. So the idea is that when we train models, there's a financial cost. It costs electricity, right? Because this 1287 megawatt hours of electricity costs them money. They have to pay a power company, right? It costs them GPUs. GPUs were tied up, right? They had to pay NVIDIA money for these GPUs. Yeah. All right. Very cool. But also has an environmental cost. Because when you burn up that much electricity, right, you're drawing power from a power station, which is burning fossil fuels, right? This is the point, it's burning fossil fuels. Yeah. I mean, if it was all electricity generated by wind power, that would be fantastic. Or solar power, even better, right? But the point is, you're burning fossil fuels to train these models. Every time you turn on a computer, you're burning fossil fuels, essentially. Yeah. But when you train a deep learning model, and especially a large language model, you're burning more fossil fuels. So there's an environmental cost, right? So this is what I'm saying. I like where we're going in some ways, right? One of the ways is that we're taking a more comprehensive view of the cost of doing business, right? We're taking a more comprehensive look at the effect of what we do. Like I say, social, environmental, financial. We always did financial, right? Human, right? Etc. Etc. Right? right? All right, very cool. So what I'm saying, so what does this have to do with callbacks? Because sometimes the teacher starts to teach this topic and then the teacher just goes off on this wild tangent, right? I'm teaching deep learning, then I'm starting to talk about the environment, right? No, but it's connected though. It's connected. So callbacks allow us to train the model just enough. Because what we're saying is when we're training our model, we're burning electricity, and burning that electricity has a cost in terms of fossil fuels, right? Right? And so callbacks allow us to train our model just enough. Because if we overtrain our model, it doesn't get any better, right? It doesn't get any better, right? And it's burning fossil fuels. Okay. Yeah. So for example, if we say, let's change this callback, right? Let's run this program, right? All right. Let's connect to hosted runtime, and let's run this program. So the callback is still there. We're not going to change the code. We're just going to simulate. We're going to simulate the situation where the callback is not in place, right? We're just going to simulate the situation where the callback is not in place. And we're going to simulate that by asking it to stop the program Wait, hold on 1 second. Sorry, I need some data. Need some data to run this. Give me 1 second. Okay, all right. Hold on a second. So here's, for example, is AI to the rescue. All right. In fact, what we're gonna do is we're gonna say generate some code to load MNIST from the internet. All right. Load MNIST from the internet. Where did we go? Where did we go? Where am I? Okay. Sorry, just give me 1 second here. All right. I'm gonna load MNIST again, right? All right, cool. Let's try this. We're gonna load it from the internet, right? All right. So we load data. All right. All right, let's rerun this. All right, yeah. So All right, so we're training our model, right? And what we've done is we're simulating a situation where we are training for 1,000 epochs, yeah? And what we're doing is simulating the situation where we don't have a callback. The simulation of not having a callback, right, is we're doing that by saying when the training accuracy gets to 1.000, then you stop the training, right? And by the way, let's go ahead and upload this to so you guys have access to it, right? Let's upload it so you guys have access. Courses, Canvas. Courses, deep learning. Let's go to modules. Let's add. Right? Let's publish this. And let's drag this over here. And then let's do one more thing. Where am I running this thing? Where am I running it? Yeah, okay. Let's do this. Let's file download. Let's download it to downloads. All right. And then we're going to upload it to all right, so it's in 001. And now we're going to upload it to 002. Right? All right, very cool. So it's available on it's available in both. It's available in both canvases, right? All right, so we're running, and let's look at our model training, right? So we said we're simulating the effect of having no callbacks, because what we've said to the callback is stop the training when it gets to stop the training when it gets to 1.00, when accuracy is 1.00. So pretty much it shouldn't ever reach 1.00, right? Because 1.0 means 100% accuracy. Yeah. Pretty much it's never going to get there. There's always going to be some loss in the model, because when you change the parameters of a model to learn one feature, kind of unlearns another feature. Yeah. Pretty much. Yeah. So in other words, let's say, for example, you have 100 items in the database, in the data set, right? As you change the model parameters, you're going to find that it's predicting one item correctly and predicting the other item incorrectly. And it might be flip-flopping. Yeah. Okay. So out of 100, 95 will always be predicted correctly. Yeah. And then as you go from epoch 16 to 17, right? Notice we're at 99, 86, 9949, 9972, 9957, 9973, 9961, etc., right? So more accurately, out of 10,000 items, for example, it's getting 27 wrong, here it's getting 14 wrong, here it's getting 31 wrong, right? Here it's getting 22 wrong, right? In other words, if you take this number from 10,000, multiplied by 10,000 and then subtract it from 10,000, right? Then you're getting 9,962. And that means out of 10,000, you're getting 38 wrong. Make sense? Everybody with me? So in other words, right? Or let's do it this way. Right? Equals that times that. Yeah? And what's happening is that yeah. So 10,000 items. And if you have an accuracy of 0.9972, it means that you're getting 9,972 correct. Yeah. And you're getting 28 wrong. Make sense? All right, cool. So you're bouncing up and down here. Here you're getting 13 wrong, 14 wrong, 18 wrong. Here you've gotten 31 wrong. Here you've gotten 30 wrong, etc., right? But understand something, it's not always the same 30, right? In other words, okay, here you have 81 and 82, right? That means you got 19 wrong here and 18 wrong here, yeah? But it's not the same 18 or 19. It's not necessarily the same 18 or 19, right? Because as you change the model weights, it allows it to predict some accurately and some inaccurately, yeah? And this is where the overfitting is coming in. Never forget this word overfitting when you're training deep learning models or large language models, right? Overfitting is your number one enemy, right? Overfitting is your number one enemy. It's not even lack of accuracy that's your number one enemy. It's overfitting, right? Because overfitting says you've confidently given somebody a model that, and you told them that out of 10,000, it will only get 20 wrong, right? But when they put it in practice, they're getting 100 wrong. Yeah. Yeah. Or they're getting 1,000 wrong. Yeah. Or worse, 2,000 wrong. Yeah. So overfitting is the number one enemy. It falls under the heading of mismanagement of expectations, because you got to manage your clients' expectations properly, right? People got to know what it is you're giving them to work with. All right. Okay. So we've simulated a situation where the callback is not stopping the training because it's waiting for it to become 1.000, and it's never going to reach 1.000. As you can see, it's bouncing up and down. Yeah, it's bouncing up and down. But what's our best accuracy that we've achieved here? What's the best accuracy we're getting here? All right. So here's what, let's do something instead then, right? All right. We don't want to wait until 9992 though, because we're getting at that epoch 30 something. Yeah. So let's say, what's the best accuracy within 10 epochs? What's the best accuracy within 10? All right, let's say, yeah, 9957? 72. All right, so here's what we're gonna do. We're gonna stop the training at 0.9972. Yeah. Now, if we go back, let's go back and let's stop the training at the original 0.99, right? That's 0.9900, right? So So let's stop the training, right? What the best possible model, but we want to also economize, yeah? Because it takes us up to 32 epochs to get 0.992. Now, and this is extremely important. I really want you to remember this point. Really want you to remember this point. Remember that we're not going to get the same accuracies the next time we train a model, right? So let's take a snapshot of what the model look like, right? Let's take a little snapshot, right? Let's rerun the model, right? Let's rerun the model. This time we're going to stop it at 0.99, which is 0.9900 effectively, right? All right. Right? All right, so we're rerunning the model, and this time we're stopping it, using the callback to stop it at 0.99. Yeah? Let's see what it does this time. All right, so let's see what it does this time. Let's see what the epochs look like this time. Right? Move this out of the way a little bit. All right, epoch 1, we got 0.9016, right? Epoch 2, our epoch 1 over here, our accuracy was 0.9016. Yeah? What's the accuracy over here? 8984. Yeah? So if you are going to say, let's stop it at epoch 32, because that's where we got the highest accuracy, right? We got 0.999, we got 3 nines, right? Then a 2. We got 0.9992. Yeah? So if we said, let's stop it at epoch 32 the second time, right? Then we're going to run into trouble because we're going to get 0.9992 at a different number of epochs the next time, right? Epoch 2, we're up to 0.9739. Here it was 0.9731, right? Epoch 3, 9850, over here was 0.9831, yeah? Now, these accuracies, by the way, they look fantastic. They look fantastic until you're looking for a license plate, yeah? Until you're looking for example, a terrorist in a crowd, yeah? Then these accuracies are not that great, yeah? If you're looking for a terrorist in an airport, in a busy airport, right? And you have a camera that's taking a quarter-second snapshot of each face, right? And you're trying to find the person before the person boards a plane. And the person is, wearing a cap, yeah? And you're trying to, and so this is where, for example, image augmentation comes in. So for example, when you watch these spy movies, you'll see people use makeup, they use disguises, right? They use things that cover their face, that change their face, right? And so if you have pictures of known suspects, known persons of interest, then you can't just use their raw picture. You have to augment their pictures, yeah? Augment their pictures to include makeup, disguises, to use the side of their face, the front of their face, right? To look for them in dark areas, when it's dark, when it's light, right? When they're smiling, when they're not smiling, etc., right? So the point is, yeah. Okay, good. So 99% accuracy. So we got there at epoch 5. Epoch 5, 6. Epoch 6, we got to 99.9, 99.19. All right, very cool. Because we said that was good enough. Yeah, we could also say, give me up to 0.97, because you've decided that you want it to be a little bit better. Because understand something, 0.99 accuracy means that out of, all right, understand something, you know. Let's jump over to our spreadsheet. This is 0.99 accuracy. Means you're getting 100 wrong out of 19 out of 10,000, right? You see the problem? In real life, that means you're getting 100 faces wrong, for example. Yeah? It means that in 100 cases, you're missing a person of interest 100 times out of 10,000, right? And if you're dealing with a crowd of 10,000, if you're dealing with a crowd of 1,000,000, right? If you're dealing with a crowd of 1,000,000, with 99% accuracy out of a crowd of 1,000,000, right? You're getting 990,000 right. You're getting 10,000 wrong. Is it a problem? And the problem, you know, you have to understand something. Once we have these systems in place, then we start to depend on them. You know, I have this brother. He's one of the ones who passed away. This guy was so wise. Sometimes I wonder how he allowed prostate cancer to get him. But anyway, he always used to say, you know, the problem with mankind or humankind is that once we develop technologies, we start to lean on them hard. We develop ABS. He always used to talk about ABS, for example, because we're always used to do these road trips. We used to drive around Jamaica, right? Even when he came here on my graduation, we drove around Ohio and Kentucky and Indiana and visited a couple of places. Anyway, the point is, he always used to say, with advancing technology, the problem is that people lean on that technology harder, right? So you develop ABS in a car. ABS allows the car to stop even in the rain. It allows the car to stop without sliding, hydroplaning, getting out of control, right? Everybody knows how ABS works. Instead of locking the brakes, it hits the brakes periodically, right? So the wheel gets to turn while the brake is clamping, right? Say lock, 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 right? So you still have steering control, because if you just kind of lock the brakes, right, and the wheel stops spinning, then the car goes out of control, right? But Paul, he always used to say how as we advance technology, people just drive harder. And people used to drive hard when it's dry. Now you drive hard when it's wet, because you know the car is capable of giving you greater control during the wet, right? Same thing with these systems, right? You have to understand that when you develop a system to detect faces, right? People are going to lean on it. So you're going to have a camera operator, right? And instead of the camera operator watching the camera for this terrorist, right? In the airport, what's the camera operator doing? He's texting his girlfriend, right? She's telling her husband what to cook for dinner, right? That's what's happening, you know. Yeah, that's what's going on. You know that, right? He's asking Beta, have you done your homework? That's what the camera operator is doing, right? Yeah. She's asking Bala, you tidy up your room yet? That's what's happening. Instead of checking the camera to see if this wanted person is coming through the airport. What they're doing is they're letting the system do it. They're letting the system, they're running the system. They're running facial recognition. Yeah. Letting the system do it. And if the system goes beep and flags a face with a red square, then there's, oh, security alert. Terminal 2, gate 5. Wanted person, right? Or interview this person. But that only happens if the system beeps, right? Only happens if the system beeps. They're looking at the system to say, okay, the system is checking. Let me also watch the camera to see if I recognize this person, right? No. They're texting, they're calling, they're checking their bank balance, right? They're checking if the kid did their homework, etc., etc. You see the point? We lean harder on systems as they improve. And so when you create a system that's going to be able to classify faces, classify whatever, right? You know, crop diseases for a farmer, right? Farmer is not walking out there in the morning and checking the leaves of the plant. Say, oh, wonder if this plant has any disease. No. Every morning, farmer deploys the drone. Drone flies over the crops. Okay, no crop disease detected. Beautiful, right? Until there is a crop disease that, you know, the drone with its fancy um with its fancy computer vision doesn't detect, right? So you have to understand. You have to understand the consequences of this 0.1, right? Even this 0.999, right? This is 0.1%, right? You have to understand the consequences of this 0.1. Yeah? You have to understand the consequences of overfitting. Yeah? All right. Because the human operators who rely on these systems are going to lean on them. Oh, wow, 99.9% accurate. That's amazing, right? But it means 1,000 people are slipping through out of every million. And it just takes one person. It just takes one person to create negative national news. See the point I'm making? All right, very cool. Okay, so anyway, so the callback allows us to stop the trading, right? All right, now we can do something even more fancy. Instead of that, we can say, write a callback to stop the training at 0.997 accuracy and save the model. Yeah. Now, 5 years ago, 10 years ago, they'd say, okay, this is how you write the callback, right? No, that's a waste of time. Yeah. You say, okay, what is the point of the callback? Why do you use a callback? Why do you need the callback? What's the value of the callback? That's what we're more interested in these days, right? Oh, let's try this again. All right, let's try this code and let's see what it does this time. All right, so this time, instead of just stopping the trading, we're going to also Oh, no, that's not what I wanted to do. What I wanted to do was, you see how great AI is? You know, we have to spell it properly. Yeah, TEH. All right, very cool. We're gonna to continue the training past, but save the model when it reaches 50 epochs. But percent accuracy. Right. All right. All right. Very cool. So this time we're gonna save the model when it gets to 99.7% accuracy. Yeah. So that means that we've saved the best model. Now, like we said, it can go up to 0.9992, right? And that again is a big difference, right? But it's gonna cost us to get to 0.9992. Oops. Hold on. What's going on here? Oh, we have it twice. Now let's see what our code does this time. Yeah, so this time it should continue the training up to 50 epochs, right? So we'll see what it actually does up to the 50 epochs, but it's gonna save the model, right? It's gonna save a model checkpoint. So we'll have that model saved and we can use that model, yeah? We can reuse that model, but we'll still see what it does up to 50 epochs. All right. Now, people, I want you to submit your poster to, I was trying to find AUM's, does anybody, I'm looking for AUM Research Day. Does anybody know about AUM Research Day?
I sent it.
You sent me an email? When is it?
April 25th, I guess.
April 25th. All right, very cool. When do you have to submit the paper? No, when do you have to submit it?
Even it's April 25th.
There is no particular date on that day.
On that day. All right. What did you search for? AUM, just AUM Research Day? And you found it?
Events.
Upcoming events?
Yeah.
Okay, you know, I saw it and I was, so then, yeah. All right. AUM Research Day. Now, 25th, right? So, on that day, we have Queen of the Court. I don't see. Oh, you know, I saw it before. But yeah, I saw this. Research and creative act. Oh, okay, so that's what they're calling it. All right, that's fine. All right, that's fine. All right. Submit abstracts here. No,
By 14.
by the 14th. All right. And now, are they going to, here's the thing. I want to give you guys extra credit for this. But it can't be if they're going to let everybody present. It has to be where some are selected and some are not. It has to be. All right. So here's what I'm trying to tell you guys. Is that if I need to find out some more information about this event, right? If it is that, okay, no, here's what we're going to do. We're going to give more extra credit. All right, so if it is selective, meaning some are selected and some are rejected, then you get extra credit. All right, you have three possible scenarios. Here's the three possible scenarios, right? Where you can get extra credit. And you're going to get extra credit for all three. All right. All right. Level 1, right? While we're training our model, right? Level 1, right? Is where level 1 extra credit. You submit. Boom. You have to have proof of submission, right? That's level 1 extra credit. That might be like 0.25% extra credit, right? 0.25% can make a difference between a A and a B, though. Because suppose, for example, you have 89.75%. No, you gotta call me up and you say, Professor Simmons, I'm 0.25% away from my A. Please give me the A. Right? And I'm gonna say, no, I'm not gonna round up. Right? Right? Now, if you're at like 89.95, I might round it up to 90 and give you an A, right? But suppose you're at 89.75, I'm gonna say, no, sorry, I can't do that. But if you had the 0.25% extra credit, boom, now we have an A. Just like that, right? So level 1, just for submitting. I still have to figure it out. Level 2, extra credit, right? Submitting and accepted. Submitted and accepted, but no selectivity. Meaning they accept everybody else, right? Right? Level 3, extra credit. So this might be like 1%. You submit, accepted with selectivity, right? That's level 3 extra credit. I may be like somewhere between 0.5% and 1%, right? Come on, you know me better than this. You know I'm gonna give better extra credit than that, right? All right. Now, by the way, this is a good time to point out a general principle by which I teach. So, as a foreign student, I don't really fail foreign students. It's not my policy, right? But if you refuse, if you don't do your work at all, I'll fail you, obviously, right? I have to. Because that's what is fair to the people who did their work. Does that make any sense at all? Can I just say, oh, well, everybody pass. Oh, let's all be happy. No, life doesn't work that way. No, you have to work hard to be happy. You have to do the work, right? So normally what I do is if you're making a CRD, if you're making an F, then you just fail. And that's it. You're done. If you're making a CRD, normally I give you extra work. I said, do this extra work, make it up to a CRD. Me, I'm always fighting with the registrar on the day when grades are due, right? Because I'm submitting grades the last minute, very, very last minute. And they're like, why you submit grades last? I said, because the people came 9,000 miles. And I'm not just gonna fail them without giving them an opportunity to correct their mistake, right? Not just because I missed something the first time or the second time. I'm gonna say, oh, you're done. I'm done with you. No, you make too much sacrifices. I know the sacrifices of a foreign student, right? So if you're making a CRD, I'm gonna give you extra work. And then I'm gonna fight with the registrar at the last minute, right? I'm kind of praising myself here, but kind of not. I'm just telling you as it is, right? All right, very cool. Good. What was the point I was making? The point is that All right, so our callback worked. Got to 0.997 and can't, no, wait, hold on. It was supposed to save the model. Wait. Wait. All right, very cool. Okay, good. Anyway, point is, extra credit if you submit your poster for research day, more extra credit if it's accepted, even more extra credit if it's accepted. As one of a few, right? All right, very cool. And that's the point I was trying to make. All right, people. All right, let's try this one again. Sometimes you have to kind of play with the. All right, okay, good. So we've modified the callback, right? And what we're doing this time is instead of canceling the training, we're saving the model. Yeah? Yeah? And it's going to be saved as model at 99.7 accuracy. Yeah? All right, let's run this and see what it does this time. Yeah? So it's going to run it up to 50 epochs. It's going to continue training regardless of what happens. But once it gets to 0.997, it will also save the model, right? So we'll save the model, but we'll also see what it continues to do after it passes the 0.997. Because the point is, we don't want to save 0.997 and feel happy, and then one epoch later, it could have been 0.998, right? At the same time, we don't want to just keep training, hoping for better, and it never gets better. So we want to save something in between. Yeah? We want to save something that's really good in between, but still see if it would have been better, right? Which is kind of like, okay, maybe that's not a great example. Okay, we won't use that example today. But anyway, all right, so you get the idea. So let's see if it works this time. And if it works, then we would have seen two ways of using callbacks. One way being to stop the model, training at a certain accuracy. The other way being to save the model at a certain accuracy, even though the model training continues, right? All right, meantime, let's see who is here today. Let's see who is here today. Should stop it. No, should stop it at this point. Well, no, sorry, it shouldn't stop it. It should save it. Uh-oh. As a matter of fact, you see what happened? It went to 0.997 and ended up at 0.9967. All right, see, 0.997 goes down to 69, goes to 68. Because what's happening is as it adjusts the model weights, it's getting some things right and some things wrong. Sometimes it ends up getting more things right than wrong, right? Than before. All right. Let's jump to deep